This is Dr. Roji. Welcome to a session on VLSI design styles. VLSI, very large scale integration. So as the name itself says, many devices are integrated on an IC. But how does this happen? Because as all of you know, the size of an IC and the size of a discrete transistor is almost the same. Then how are we able to incorporate these millions of transistors on the same IC? So for this we need some design styles. The two design styles will start with a full custom design style. The VLSI design can be classified as full custom, semi-custom, PLD design and system on chip design. In the coming slides, we will see the different design styles one by one. The different the different processes which are involved in the physical design are floor planning, placement, routing, etc. So in the full custom design, everything is decided by the designer, starting from the floor planning up to the routing. So as we can see here, the full custom, the designers can control even the shapes of all the mask patterns and they can specify the design. So what must be the advantage and what must be the disadvantage of this? The advantage is that everything you can decide. You can make the IC as per your requirement. Whereas the disadvantage is the design effort is huge and also the time taken is also very large. So this full custom design can be used only when the need is desperate. The main disadvantage of the full custom is, of course, the time taken to market. The next type of design is the semi-custom. As the name itself says, it is a combination of full custom and something which you can allow the machine to do. So all the logic cells are pre-designed and some of the mask layers are customized, unlike the previous case where everything was customized. And here we also use pre-implemented layouts. Yeah, semi-custom can be cell-based or array-based. So cell-based and array-based, we'll explain them, we'll see them with necessary diagrams. So cell-based ASIC. The cell-based ASIC has a standard cell area and there are also fixed blocks. What is a standard cell? In a standard cell, we will have rows of cells. The height of the rows will all be fixed, whereas the width will change. So depending upon the size of the logic, the width can be changed, whereas the height remains the same. The fixed blocks which you see here in this diagram is nothing but the ASIC which you have made by using the full custom design. Yeah, the array-based semi-custom design. The array-based semi-custom design can be classified as channel gate array and channel-less gate array. We'll see them. First, we'll see about the channel gate array. Okay. The channel gate array, the diagram has been shown here. From this figure, we can see a row of cells with the place in between them. And something has been written as the base cell. This base cell is the smallest element which can be replicated to make the base array, right? And this space which has been given between the rows is for routing, or it is used for giving the interconnections, right? The next type of gate array is the channel-less gate array. Yeah, this channel-less gate array, you can clearly observe the difference between this one and the previous one. In this one, we do not have a place for giving the interconnections. There are no predefined areas as can be seen here for routing. Routing is over the top of the gate array devices, right? So what must be the advantage of this channel-less? Obviously, the logic density is higher. The logic which can be accommodated here is higher than that in the case of channel gate array. Okay. Okay. Now we'll go to the next one. The next one is programmable logic. Programmable logic can be classified as PLA, PAL, and PGA. Programmable logic array, programmable array logic, and programmable gate array. So as we have seen here, programmable logic array has an AND array and an OR array. The next one, PAL, also has the same, but in the case of PLA, both the arrays are programmable. If you have a confusion over it, I want you to go back and think about the two-level AND OR network. First, we have the AND connection of gates, and then we have the ORing. It's almost similar, except for the case here the array is fixed, whereas there we can choose the number of gates according to our design. Okay. So the next one is PAL. In PAL, as I said, the programmable AND array. The AND array can be programmed, whereas the OR array is fixed. Right? Next comes the programmable gate array. All of you are very familiar with the PGA. The field programmable gate array, or FPGA, is the main classification of your PGA. We have CLBs, configurable logic blocks, IO blocks, etc., by which the different gate arrays can be programmed. Okay. The next one is a system on a chip. When the people started working with systems, the system will be will be of the size of a room. But now everything has become so simple, and you have everything on the palm of your hand, right? So the main components of a system on a chip, the whole system is on a chip. What are the main components of the SoC? The processor, the GPU, which is the graphics processing unit, the memory, which consists of the RAM, ROM, cache memory, etc., IO interfaces, DSP, which is your digital signal processor, and hope you enjoyed the video. Meet you in the next session with some more information. Thank you.